Millions of years ago, Antarctica looked nothing like the frozen continent we know today. It was once a lush, warm, and thriving near paradise of conifers and ferns, teeming with life forms that could astonish even the most seasoned paleontologists. The climate, the ecosystems, and the creatures that roamed this ancient land tell a story far more fascinating than most people realize. 190 million years before the T-Rex became the most feared predator on Earth, something was already wearing a crown. And it was doing it in Antarctica. This is the prehistoric world of the Cryolophosaurus, a unique crested predator that once roamed these southern forests long before the continent was buried under ice. Our journey uncovers the dramatic environmental shifts that transformed a green wilderness into a frozen wasteland, highlighting the diverse flora and fauna that thrived in this ancient warmth. We can examine the geological and biological fossil evidence that proves that Antarctica was once a hub of biodiversity. From the towering trees to the formidable dinosaurs like Cryolophosaurus, we can view the incredible details of this lost world. The continent's hidden history shows a transformation from a near-tropical haven to the icy, locked frontier we recognize today. This was a time when the South Pole was unrecognizable. I should add at this point, for the sake of accuracy, that Cryolophosaurus and Glaciolosaurus belong to early Jurassic Antarctica, roughly around 188 million years ago. Antarctopelta, hadrosaurs, and Antarctic titanosaurs are late Cretaceous Antarctic animals. So despite this video's liberties with a bit of colour impact and all, I am adhering to timeline constraints in prompting here. Cryolophosaurus and Glaciolosaurus are tied to the early Jurassic Hansen Formation, while late Cretaceous Antarctic dinosaurs are known from the James Ross Basin and related Antarctic Peninsula deposits, and avid hobbyist paleontologists may notice attempts to reflect these environments at points during the narrative. We only know Cryolophosaurus exists because of one of the most grueling fossil expeditions in the history of paleontology. Finding dinosaur bones is hard enough when you're digging in uncomfortable desert conditions in Montana or the Gobi. The paleontologists here were working on a frozen mountain in Antarctica. Augustana College's Professor Hammer and his team did this back in 1991. They were excavating at the site called Hansen Formation in the Trans-Antarctic Mountains, working at elevations above 13,000 feet, dealing with brutal cold, thin air, and terrain that made every single day of fieldwork feel like a survival challenge. And what they found was extraordinary. They uncovered the partial remains of a large theropod dinosaur, a two-legged predator, unlike anything that had been found before. The bones were significant. A partial skull, vertebrae, limb elements, and enough material to give scientists a genuinely good picture of what this animal looked like in life. The specimen was eventually described formally in 1994, and that's when the name Cryolophosaurus ellioti was officially given to the world. The name breaks down beautifully. Cryo means frozen, lopho means crested, and saurus means lizard. So the full translation is essentially frozen crested lizard. One of the weirder things about this theropod is that while most crested theropods, and there are quite a few throughout dinosaur history, have crests that run parallel to the length of the skull, it has a crest that runs from right to left, that is side to side. That makes this animal instantly memorable and completely distinctive from every other theropod ever discovered. But let's not let giggles distract us from how scientifically significant this crest actually is. The forward-sweeping, fan-shaped crest of Cryolophosaurus is a unique anatomical feature found in no other known dinosaur. It was almost certainly not used for any kind of aerodynamic or combat purpose. The crest was too thin and fragile to function as a weapon. Instead, most paleontologists believe it served primarily as a display structure. Visual signaling. Think of the elaborate plumage of modern birds, the bright colors of certain lizards, the antlers of deer. These structures exist to communicate information to other members of the species. They can signal dominance, attract potential mates, identify individuals within a social group, or help establish hierarchies without the need for dangerous physical confrontation. Think of Dilophosaurus with its double crests running side by side along the top of the snout. Standard stuff in the crested predator world. Cryolophosaurus does something completely different. Its crest runs perpendicular to the skull, meaning it sweeps forward and upward like a fan or a pompadour hairstyle. When today's raised on rock and roll scientists first saw this feature, the comparison was unavoidable. Or they might have been just a bit giddy from the high-altitude cold overexposure as well. At any rate, this nickname is still referred to today by many otherwise quite stodgy academics. As mentioned earlier, we see crests in Dilophosaurus from the early Jurassic of North America. We see elaborate head ornamentation in later theropods like Carnotaurus with its bull-like horns, and the Jurassic predator Guanlong with its elaborate nasal crest. We see crest-like structures in some spinosaurids. The repeated evolution of prominent head displays in predatory dinosaurs strongly suggests that visual communication was a fundamental part of how these animals interacted. This pattern mirrors what we see in modern birds, which are, of course, the living descendants of theropod dinosaurs. The elaborate plumage of peacocks, the colourful facial features of toucans and hornbills, the crests of cockatoos and cassowaries. All of these structures serve visual communication functions. The deep evolutionary roots of this tendency toward visual display go all the way back to animals like Cryolophosaurus. When you see a parrot with a colourful crest, you're looking at an echo of behaviour and anatomy that stretches back nearly 200 million years to a frozen mountain in ancient Antarctica. That connection across deep time is genuinely beautiful. Everything else about Cryolophosaurus was decidedly less glamorous and considerably more lethal. This was not a delicate or lightly built creature. Adult specimens reached approximately 7 meters, or around 23 feet in total length, and weight estimates for mature individuals range from roughly 500 kilograms up to perhaps 650 kilograms, placing it solidly in the heavyweight category. To put that in perspective, it was heavier than most modern bison and approached the mass of certain small rhinoceros species. It also holds a genuinely impressive distinction beyond just being the most famous Antarctic dinosaur. As of the current fossil record, Cryolophosaurus is the largest theropod dinosaur known from the early Jurassic period anywhere in the world. Not just the largest in Antarctica, not just the largest in Gondwana, but the largest early Jurassic theropod on the entire planet. That is a remarkable title, and it gives you a sense of just how dominant this animal was within its ecosystem. This animal lived at high latitudes where seasonal variations in daylight were significant. Unlike dinosaurs living near the ancient equator, Cryolophosaurus would have experienced extended periods of darkness during the Antarctic winter. Not the complete darkness of modern polar winters, because the climate was warmer and the continent was positioned slightly differently, but still significant seasonal light variation. How did a large predatory dinosaur cope with this? This question connects to the larger debate about dinosaur physiology and metabolism. Modern science has moved well past the old idea of dinosaurs as cold-blooded reptiles that sat in the sun to warm up. There is now overwhelming evidence that at least the theropod dinosaurs, the group that includes Cryolophosaurus, had metabolisms that were significantly elevated compared to modern reptiles. Some researchers argue that many theropods were effectively warm-blooded in a way not entirely unlike modern birds. The presence of a large theropod in a seasonally cold, high-latitude environment supports this hypothesis. A cold-blooded animal simply could not maintain the activity levels needed to be an effective apex predator in that kind of environment. Cryolophosaurus almost certainly had a high-energy metabolism that allowed it to remain active through the cool Antarctic seasons. Way back in the aftermath of the Great Dying, when the Triassic period began, most of the Earth was a hot, arid wasteland. But Antarctica, positioned nearer to the South Pole even back then, was actually cooler than the rest of Pangaea. And that cooler climate made it a refuge, a sanctuary for survivors looking for somewhere that was somehow still livable. We know this thanks to fossils discovered in what is now called the Fremau Formation, in the Transantarctic Mountains. It was once a giant floodplain, crossed by rivers and bordered by forests. The fossilized remains of cycads, horsetails, ferns, and ancient seed ferns have been found here. And most notably, none of these plants show any signs of cold adaptation. This tells us that this region was genuinely a warm and hospitable location. A green, fertile corner after the Great Dying in the mostly still devastated world. Lystrosaurus lived in these early Triassic forests. This herbivorous synapside was more closely related to mammals than to reptiles or dinosaurs. It was a stocky, sturdy little plant eater, and it was extraordinarily successful in those tough years following the Permian extinction. A survivor animal in the truest sense. In the early Triassic, Lystrosaurus made up about 95% of all land animal biomass. Almost everything alive on land was a Lystrosaurus. The fact that we find its fossils not just in Antarctica but also far away in Russia, South Africa and India was actually one of the pieces of evidence that helped scientists prove the continental drift theory. Because Lystrosaurus was a land creature, there is no way that this chunky little landlubber package swam across open oceans to get to those places. It walked there when the continents were still connected. Alongside Lystrosaurus, early Triassic Antarctica hosted other synapsids, including a small fox-sized carnivore thought to have fed mainly on insects, as well as various ancient reptiles. Prolacerta, for example, looked superficially like a lizard, but was actually more closely related to the archosaurs, the evolutionary lineage that would eventually produce crocodiles, dinosaurs, and birds. It belonged to the same archosaur-related group as the iguana-sized reptile called Antarctanax. Its discovery actually pushed scientists to theorize that archosaur lineages must extend much further back into the Permian than previously known. These hidden ancestral lines with no fossil record yet to confirm them are known as ghost lineages. In the early Triassic, Antarctica was a warm, thickly forested floodplain that was home to a thriving ecosystem of synapsids, early archosaurs, and amphibians. The most commonly found fossils from this period are those of the Lystrosaurus. This herbivorous dicynodont, which are distant relatives of mammals, is described as ranging somewhere from the size of a large pig to a hippo, with a beak resembling that of a turtle. These creatures even developed a form of hibernation in order to survive extended periods of polar darkness. Archosauriforms, like Antarctanax shackletoni, tended to resemble iguana-sized salamanders for the most part, and seem to have been some of the most dangerous early carnivores in this environment. Prior to the evolution of dinosaurs, early Triassic Antarctica teemed with swamp-dwelling temnospondyle amphibians and early mammals like Lystrosaurus. Prolacerta dwelled on the edges of riverbanks and was a slender, lizard-like archosauromorph insect hunter, while Cryostega was a massive top predator, labyrinthodont, amphibian that could grow up to 15 feet long and resembled a giant salamander. In the Cretaceous era, at the opposite end of that Antarctica prehistory timeline, we find Imperibeta antarcticus. It is estimated to have been a mid to large-sized predator comparable to Deinonychus or Nuconraptor of around 2 to 3 meters long, although some early estimates pointed to even larger proportions as being quite likely. Paleontologists still debate its exact taxonomic placement, possibly due to some unusual features, such as a fossil lacking the signature sickle claw seen on many other dromaeosaurs, and a decidedly limited collection of fossil specimens. This swift and agile polar predator was discovered in the late Cretaceous strata of James Ross Island and lived about 71 million years ago in an ecosystem that featured temperate conifer rainforests and coastal environments habitats. Antarctica holds about 90% of all the glacier ice on Earth, with ice sheets in some regions stretching downward for nearly 3 miles before hitting solid rock. But there was a time, deep in the geological past, when that same land was something else entirely. A steaming, dripping, sun-drenched world of dense forests, rivers, swamps, and creatures so bizarre and so terrifying that they would fit comfortably in any science fiction film. And standing right at the center of that ancient world, as one of its earliest and most iconic predators, was the dinosaur that was nicknamed Elvisaurus, and that totally stood out in a crowd, namely Cryolophosaurus. Today we are going into that lost world, beginning with the Jurassic period, which is precisely where our main character calls home, and then working our way forward through time to understand how Antarctica transformed from a living, breathing, thriving wilderness into the frozen tomb it is today. This story has everything: jungles, monsters, volcanic catastrophes, and more than one seriously metal-looking star. The geography matters enormously here. When most people hear the word Antarctica, their brain immediately generates an image of a flat white expanse stretching to the horizon in every direction. That mental picture is completely reasonable given the world we live in today, but it would have been utterly unrecognizable to any creature alive during the Jurassic period, which began roughly 201 million years ago. At that time, Earth looked nothing like it does now. The supercontinent of Pangaea was already deep into its long, slow process of breaking apart, but enormous chunks of it were still attached to one another, and Antarctica in particular was connected to several other major landmasses. It seems to have even served as a migration highway as gigantic titanosaurs migrated from South America across Antarctica and into Australia. The continent was also positioned significantly further north than it sits today, nowhere near as close to the South Pole as its current location would suggest. Combined with the naturally warmer global temperatures that defined the Mesozoic era, courtesy of elevated atmospheric carbon dioxide levels, this meant that the Antarctic region was not just ice-free, but genuinely warm and hospitable. Temperatures during the early Jurassic in the region of what is now known as the Hansen Hill Formation, located on Mount Kirkpatrick, have been estimated at around 17 to 18 degrees Celsius, which is roughly comparable to the climate of southern Chile today. Not tropical in the blazing beach holiday sense, but absolutely lush and green by any standard. The landscape itself would have featured dense forests, dominated by ancient conifers, ferns, and a group of plants called bennettitales, which are long-extinct relatives of cycads that produced rather beautiful flower-like reproductive structures. Rivers snaked through the terrain, lakes formed in depressions, and swampy areas dotted the lowlands. It was of a continent bristling with life, with water flowing across its surface and vegetation carpeting nearly every available patch of ground. It was into this environment that the first dinosaurs arrived in Antarctica, and as far as current fossil evidence tells us, the story of dinosaurs in Antarctica begins primarily at Hansen Hill. Several types of early dinosaurs have been found associated with this formation. There were small primitive sauropodomorphs, which were the ancestors of the great long-necked giants that would come later, but at this point looked nothing like them, being bipedal, modestly sized, somewhat deer-like in their proportions. There was also Glacialisaurus, a more robust member of the same group that grew to around 6 meters, or roughly 20 feet long, and carried a weight comparable to an Asian elephant. The creature that truly defines Jurassic Antarctica, the animal that stands as both its most famous resident and its undisputed apex predator, is Cryolophosaurus. The comparison ends firmly at the hair because everything else about Cryolophosaurus was decidedly less glamorous and considerably more lethal. This was not a delicate or lightly built creature. Adult specimens reached approximately 7 meters, or around 23 feet in total length, and weight estimates for mature individuals range from roughly 500 kilograms up to perhaps 650 kilograms, placing it solidly in the heavyweight category. To put that in perspective, it was heavier than most modern bison and approached the mass of certain small rhinoceros species. It also holds a genuinely impressive distinction beyond just being the most famous Antarctic dinosaur. As of what we currently know from the fossil record, Cryolophosaurus is the largest theropod dinosaur known from the early Jurassic period anywhere in the world. Not just the largest in Antarctica, not just the largest in Gondwana, but the largest early Jurassic theropod on the entire planet. That is a remarkable title, and it gives you a sense of just how dominant this animal was within its ecosystem. In terms of how it hunted and what it ate, the anatomy tells a clear story. The arms were powerful and equipped with claws designed for grasping. The teeth curved inward, which is a design feature seen in many predatory dinosaurs and is thought to help grip and secure struggling prey rather than allowing it to wrench free. Fossil evidence from the Hansen Hills site includes material from other animals bearing what appear to be Cryolophosaurus bite marks, which confirms that this was an active predator of other dinosaurs. Smaller theropods and those primitive sauropodomorphs we mentioned would have been reasonable prey items for a fully grown adult. For juveniles, smaller non-dinosaurian animals would also have been on the menu, including flying reptiles related to dimorphodontids and small mammal-like reptiles called cynodonts. Perhaps the most striking and slightly disturbing aspect of the Cryolophosaurus fossil record is evidence of cannibalism and scavenging among members of its own species. Multiple specimens show signs of having been fed upon by other Cryolophosaurus, and in one rather extreme case, evidence suggests a juvenile animal was feeding on the remains of a much larger adult of its own kind. This tells you something important about the environment these animals lived in, because the Hansen Hills site preserves not just dinosaur bones, but also massive accumulations of volcanic material, indicating that the region experienced frequent and violent eruptions during this period. Pyroclastic flows, lava advances, and the wildfires that these events triggered would have periodically devastated the landscape, burning forests and destroying food sources. The resulting scarcity would have pushed animals into desperate behavior, and cannibalism in a predator during times of resource stress is not particularly surprising when you understand the pressure the environment was placing on them. These volcanic events were catastrophic in the short term, but over longer time periods they also enriched the soil, contributing to the fertility that helped sustain the forests these animals depended upon. Now, at this point, we should acknowledge that the Jurassic, despite all its drama, was not actually the most spectacular chapter in Antarctica's long story. It was an important chapter, arguably a foundational one, because it established Antarctica as a genuine dinosaur habitat and introduced the world to some remarkable creatures. But the continent had a long way to go, and in some respects the Jurassic was merely the opening act. As Pangaea continued pulling itself apart over the following tens of millions of years, Antarctica gradually separated from more and more of its neighbouring landmasses. India broke away and drifted northward. Australia remained connected for longer, and the two continents exchanged animals as a result. But eventually, even that connection faded. By the time the late Cretaceous arrived, roughly 85 million years ago, Antarctica was essentially isolated, maintaining only intermittent land bridge connections with South America and Australia at various points. Its climate had also shifted, becoming somewhat more humid and seasonally variable. Fossilized soil samples suggest that late Cretaceous Antarctica was broadly comparable to temperate zones we know today, and during summer months, the mean temperature could climb to around 25 degrees Celsius, which is roughly equivalent to what you would experience in Kenya on a typical day. The forests had changed too, with flowering plants becoming increasingly dominant alongside podocarp trees and Araucarian conifers. But there was a complication. Winter in Antarctica, even during the Cretaceous, brought extended periods of darkness. The continent's polar position meant that for months at a time, the sun barely rose above the horizon or did not rise at all. Scientists estimate that the region could have experienced up to 4 months of near-total darkness each year, with only starlight, moonlight, and the occasional glow of volcanic activity providing any illumination. That is a profound challenge for any animal trying to survive there. And yet life adapted, and the dinosaur fauna of late Cretaceous Antarctica was remarkably diverse. Ankylosaurus roamed through the forests, their bodies armoured with bony plates. Ornithopods browsed on the vegetation. Evidence suggests that titanosaur sauropods, members of the largest land animal group ever to walk the Earth, also traversed this continent, and, among the predators, a feathered paravian called Imperabator, a large and robust hunter over 3 meters long, used powerful limbs and curved bladed teeth to make its living in the perpetual semi-darkness. But that dramatic late Cretaceous world met a violent end approximately 66 million years ago when the asteroid impact that defines the end of the Mesozoic sent its shockwaves around the globe. Studies of Antarctic marine fossil deposits spanning from about 70 million years ago to roughly 1 million years after the event show approximately a 70% species disappearance at precisely the extinction boundary. The continent was not spared. The tsunami that reached its coasts was estimated at around 10 meters tall. The superheated atmosphere ignited anything exposed to open air, and the subsequent blocking of sunlight by ejected debris plunged the world into an extended cold period. Antarctica's extraordinary Mesozoic chapter was closed. What came afterward is a separate story of remarkable recovery and eventual tragedy. But let us appreciate for a moment what we have already explored. A continent that today supports almost no terrestrial life of any meaningful size was once home to the largest land predator of the early Jurassic period. Forests of ancient conifers covered ground now buried under miles of ice. Rivers and swamps provided habitat to an array of creatures that would look utterly alien to anyone alive today. And reigning over it all during those earliest known Antarctic dinosaur years was Cryolophosaurus, the frozen crested lizard with the truly metal rock star hairstyle, stalking through dense Jurassic forest on a continent that barely resembles a fragment of what it once was. After the asteroid's devastation, the planet did not remain cold forever. Temperatures actually climbed dramatically during the Paleocene and Eocene epochs, fueled by rising carbon dioxide levels that pushed global climate into what geologists call a super greenhouse state. Antarctica, still not quite as far south as it sits today, experienced this warming intensely. During a peak event known as the Eocene thermal maximum, average temperatures in Antarctica may have hovered around 25 degrees Celsius, comparable once again to warm modern tropical nations. Palm trees and vegetation more associated with tropical islands colonized the continent. It was arguably greener and more biodiverse than at any previous point in its history. Mammals arrived via land bridges from South America, including large rhinoceros-like herbivores and strange creatures with specialized teeth for processing the abundant plant life. Terror birds stalked prey through the forests. Giant crocodilians lurked in rivers and coastal waters. Enormous penguins standing taller than professional basketball players dove through warm Antarctic seas alongside ancient whales that still possessed teeth and hunted actively. And then, around 34 million years ago, the temperature just collapsed. Antarctica completed its separation from South America and Australia, and the formation of the Antarctic Circumpolar Current cut the continent off from warm ocean water reaching its coasts. Carbon dioxide was pulled from the atmosphere. Ice sheets began forming. The animals that had thrived in the warmth could not adapt fast enough to the rate of change. Over the following millions of years, the continent's biodiversity plummeted. The forests retreated. The terror birds and crocodiles vanished from the fossil record. The giant penguins disappeared. The land that had hosted successive waves of extraordinary life across nearly 200 million years was finally and permanently surrendered to the ice. What lies beneath that ice today remains genuinely unknown. The formations we have found, the fossils we have pulled from exposed rocks in places like the Antarctic Peninsula and the Transantarctic Mountains, represent only a tiny fraction of a continent that is larger than both Europe and Australia combined. There could be entire ecosystems, entire evolutionary stories, buried under kilometers of frozen water waiting to be discovered. What we already know is astounding. The ice continent was once a continent of life, a frozen wasteland that was once a jungle. How many other astonishing and unique animals are still buried in rock, waiting to be discovered? The discovery of Cryolophosaurus in 1991 is a reminder that extraordinary things are still out there waiting to be found, and that the story of life on Earth is far stranger and wonderful than previously imagined.